Okay, three of the roots of this fifth degree polynomial are given to you, and there's two unknown roots. So we've been doing these for a while, and certainly been doing them by plugging numbers in. It gets a little tedious over time. So we'll talk about the method that's really that Wells addresses in this text. So what I want to claim over here is that we certainly know from what they've told us that this thing factors into this over here. Now, why is that? They're giving us the root 2, minus 3, and minus 4. What I don't know is the other two roots. What I want to claim, though, that if you did a long division, right, if you took a long division, if you divided this into the polynomial, you get the depressed equation. And that depressed equation will be the form x minus a times x minus b, which would be what? It would be, let's see, x squared. And then you would get, minus ax minus bx. So let's just simply say minus a plus bx plus ab. All right? Now, the other thing I want to mention is that I think you probably have some understanding that there's a relationship between the coefficient and the roots. Some relationship, right? So one thing I want to claim over is, really quite easily, just looking at the depressed thing, and I can figure out what AB is like pretty quickly. All right? And what I mean by that is just set x to be 0. And we've done that before. Let me do that again. So if you set x to be 0, you get minus 720 equals, well, what would you get there? You'd get AB. Again, I'm setting x to be 0 there. Then you get what? Let's see, minus 6, minus 24, right? So AB would have to be, let's see, what would that be? That would be 30, right? 3 times 24. Yeah, 30. All right, so AB is 30. All right. Well, that's not such a bad idea, is it? So what do you get over here? Let me write this down for you. X squared. And let me see, the sum product. Let's put this over here. We'll talk about that internal term over there. All right, let's talk about what Wells is suggesting you do at this point. He says, if all but two, let me outline that for you. If all but two roots are known, the coefficient of the second term of the depressed equation, right? The coefficient of the second term of the depressed equation may be found by adding the sum of the known roots. Let me write that down. What are the known roots? Let's write this down. 2 plus minus 3 plus minus 4 may be found as sum of the coefficient of the known roots. Okay, may be found by adding the sum of the known roots to the coefficient of the second term of the given equation. Minus 11. I'm sorry, minus 6. I'm sorry, I didn't say, I'm thinking minus 11 for some other reason, by the way. What do you get over here? 2, minus 1, minus 5, minus 11. All right? So what's this over here? This could be x squared minus 11x plus 30. What's a and b? I think it should be somewhat obvious right now. Let's write this down. It's a quadratic, super easy to factor. X, 6, 5, minus. So the other two roots are 5 and 6. All right? Now granted, because you've gotten it another way, of course you could have, but the bottom line, it's not a bad way to go about doing the problem, all right? All right, we'll talk about that in more detail as we start moving through the problem set. Thank you.